A lack of rain in recent years meant the northeast of the country is seeing its worst.
The modern-day media is this negative sphere that is constantly being that devil in your ear, telling you about the world's most recent tragedies. While news stations and the media are important tools to help you learn about the world around you, often the crises we've been told about have seen positive progress.
Of the world's first malaria vaccine.
Take the ongoing water problems our planet faces. You hear about South Africa, Spain, Mexico, and Bolivia. But have you heard about how one country turned water from diamond to coal? That is the story of Israel.
The Middle East and North Africa region is known to be one of the most dry and arid regions in the world, meaning all the countries there receive little to no annual rainfall. When we look at countries with water scarcity, many that come to mind originate from this region. Qatar, Yemen, and Syria are all prominent examples. Another country that historically struggled with water in this region would be Israel. From as far back as 5,000 years ago, the city of Jerusalem was dependent on one main water source, the Gihon Spring.
The Gihon Spring brought prosperity and water to the people of Jerusalem for centuries, bringing water to the Kidron Valley. But like various other fresh water sources, it has begun to dry up as a result of global warming and a decrease in rainfall. Couple that with Israel's massively expanding population, and the seeds for a water crisis are already present. And that is exactly what happened.
Israel's water resources were running out, coastal aquifers becoming more polluted by the day, and even lakes like the Sea of Galilee's survival is under threat as its water is being put in strain. Rainfall was at a record low, and even ration policies were created for farmers. 16,000 acres of orchards destroyed for the conservation of water. Civilians were running out of potable water, and something needed to be done. But what?
In early 2002, after a cataclysmic 4 years of drought, the Israeli government had had enough. The solution? Desalination. While 71% of the Earth's surface is covered by water, only 3% of it is freshwater. Furthermore, less than 1% is actually accessible to us, as the rest is either trapped underground or frozen in the form of glaciers. This means that, in reality, we only have access to a tiny portion of Earth's water. But what if we were able to turn this salty water into freshwater? That's where desalination comes in. It's a process of converting salt water into freshwater, and it's how Israel planned to solve their water crisis.
While there were already a few previously built water desalination plants in Israel, there weren't nearly enough. Thus, the government approved the construction of a large-scale seawater desalination project along the Mediterranean coast, comprising 5 major plants. These would supply 305 million cubic meters a year of desalinated water by the year 2010 and 500 million cubic meters by 2015. IDE Technologies was given the grand task of establishing 3 of the big 5 desalination plants. Ashkelon was the first to be completed in 2005. Hadera followed in 2009, and finally, Sorek was completed in 2013. Today, Sorek is considered the largest seawater desalination plant in the entire world, with a total capacity of 624,000 cubic meters a day. For more than 2 decades, Israel has been taking seawater from the Mediterranean and treating it using desalination. Somehow, this tiny nation went from being a severely water-depleted country to one of the world's leading water giants. How? Simple. Reverse osmosis.
Reverse osmosis is a method of desalination that uses pressure to force substances through a semi-permeable membrane. The membrane is selective, so it rejects larger molecules, such as salt, while letting in smaller ones, such as water. This leaves us with fresh, potable water. While this is only one method of desalination, it is often deemed the most effective.
But while this method is extremely effective, often the cost is too much for people to get behind. To build one 2.5 mgd desalination plant, an estimated $32 million is required, while $658 million for one of 100 mgd, and many of Israel's desalination plants can easily convert 168 mgd. This process may be costly, but for some, it is their only option.
We are facing a global water crisis. It is approximated that 2 billion people don't have access to potable drinking water. the global urban population facing water scarcity is expected to double within the next few decades. So if Israel is able to make such huge advancements, why aren't more countries following their lead? Why aren't more countries using desalination?
As mentioned earlier, while ocean water is a tempting resource, the process is largely energy intensive, costly, and is not always beneficial for the environment. In the end, producing enough water for the entire global population using desalination may have even worse long-term effects on our planet.
But even though desalination alone cannot solve the water crisis, it may be able to help as part of a broader range of efforts to increase water supplies. In the future, we could be seeing desalination as a commodity in countries where water is desperately needed, and there are little to no alternatives.
At the end of the day, desalination in Israel teaches us an important lesson, one of innovation. We have already overcome so much adversity. Why stop now? The ability to overcome trials and tribulations is what has brought humanity to where it is today. Amid a global water crisis, a tiny nation arises. Israel's story gives us hope for the present and inspiration for the future. After all, the water crisis is threatening the very future of mankind. Whether we pull through or not is solely up to us.